Yeah, I'll react to that, sure.
94 parts that make up an engine. Well,
Uh, I really want to learn solidly how an engine works, and I'm not there yet, and I'm ready to learn.
this is a fuel injector. It sprays gasoline into your engine, and it's just one out of 94 parts that make up an engine. Well, more specifically, that make up the Honda D15 engine. In this video, we're going to assemble a D15, and along the way, explain each and every individual part that goes into it. From the obvious, like the pistons, to the slightly more obscure, the valve spring retainers. Do you know every single part that goes into an engine? Well, you're about to. Let's start with the basics.
Do I know
a piston is attached
a single crap, I'm sorry guys, was I out of view? That should be changed to
engine?
Do you know any single part that goes into an engine? And the piston, spark plug.
Well, you're about to. Let's start with the basics. A piston is attached to connecting rod via a wrist pin. On the bottom of the connecting rod is a crankshaft.
Stop. Start.
Goes into an engine? Well, you're about to. Let's start with the basics. A piston is attached to connecting rod via a wrist pin. On the bottom of the connecting rod is a crankshaft bearing. This minimizes wear and allows the connecting rod to rotate smoothly when attached to the crankshaft. A rod cap holds the other end of the connecting rod onto the crankshaft, completing the connection. Now, as the piston moves down the inside of a cylinder, it draws in an air-fuel mixture. A piston compresses that mixture, which is then ignited by a spark plug. The resulting combustion pushes the piston back down, and then as it returns to the top, it pushes out exhaust gases, and the cycle continues.
Okay, but how does... That's really cool. It's like a bike pump. You know, like you suck it in to get more air, and you blow it out. Or like you pull the lever up, it sucks in, you push it down, it compresses. But I wonder how, okay, like that's taking air in and then compressing it to combust with fuel. But how does that combustion energy translate to moving the tire? How does that go from that to making your tire turn? Frickin'.
The top plug.
That's really cool, though.
Combustion pushes the piston back down, and then as it returns to the top, it pushes out exhaust gases, and the cycle continues. Sucking in air and fuel, compressing it, igniting it, and then pushing out the exhaust. Now, that process is what gets the crankshaft spinning, which spins the transmission, which spins the drive shaft, which spins your wheels. Okay.
But how?
Okay, so that's the basic.
But
exhaust. Now, that process is what gets the crankshaft spinning, which...
How does the explosion get the crankshaft spinning? I want to know.
Spins the transmission, which spins... The process is what gets the crankshaft spinning, which spins the transmission, which spins the drive shaft, which spins your wheels. Okay, so that's the basics out of the way. But to cover each and every part that goes into this engine, we're going to have to break it down into 6 systems. The rotating assembly. That's the central mechanical system at work. Timing. A lot is going on inside an engine, and those moving pieces need to work in unison. Cooling. Engines want to get hot, so you need a system to keep them from overheating. Airflow. If you want to burn fuel, you need oxygen in the equation. Electrical. Whether it's a modern car or a 50-year-old beater, a functioning engine needs a functioning electrical system. And finally, and maybe most obviously, fueling. Okay, so in order for compression and combustion to take place, we need a strong, sealed combustion chamber. That is our engine block, and it forms the cylindrical walls of the chamber, while piston rings mounted on the outside.
I thought these things weighed like 4,000 pounds, and he's just lifting it. So I was wrong there.
And it forms.
I was misinformed.
A strong sealed combustion chamber, that is our engine block, and it forms the cylindrical walls of the chamber, while piston rings mounted on the outside of the piston ensure a tight seal. Now in our case, the top two rings are called compression rings, and they form a seal between the piston and the cylinder wall, while the third ring, called an oil control ring, distributes a thin layer of oil on the cylinder so the piston can move smoothly up and down. Now inside the block are various coolant and oil passages called galleries to help keep the engine cool and lubricated. Looking at the engine block upside down, you can see the semicircular cutouts that will house the crankshaft, which are fitted with crankshaft bearings and
I thought those were just screw holes.
Engine cool and lubricated. Looking at the engine block upside down, you can see the semicircular cutouts that will house the crankshaft, which are fitted with crankshaft bearings and two thrust bearings that prevent the crankshaft from sliding back.
Can one of you admit in the comments you lied to me about the weight of the engine block? Because you were very convincing. And I thought these weighed, either he's the strongest man in the world, or this is the tiniest engine block in the world, but that's not a ton. That's not 2 tons. That's not a half a ton.
Back and forth. Thrust bearings that prevent the crankshaft from sliding back and forth. Okay, good job, boys. That's pretty cool. Now, we have a quick word from our sponsor today, which is Mother's, but you guys can work on getting the pistons put in while I go to the little boys' room. Okay, I gotta take a leak. Bad timing.
What's that? Oh, it's the odor eliminator and refresher from today's sponsor, Mother's Polish. It'll destroy 90...
Now, guys, fast forwarding is up to you guys. Any video I watch that is a sponsor advertisement, I'm going to watch it. It just feels wrong for me not to. If this interests you and you learned it from watching me watch this video, please just make sure, even if you do buy it, just using the promo codes, the links, original link to the video, top of the description, it means a lot. It means that their advertisers are seeing good money from the ones they're sponsoring, and it helps them out. This is their video, their content. That's why I emphasize this so much every time, guys.
99% of odors from your car. Talking mildew, pet smells, old food, anything really. How's it work? Start the car, close the windows, turn the AC to max cold, set the fan to high, and make sure recirculate is on. Give the can a good shake, put it in the cup holder, press the locking lever, and get out. In just 15 minutes, it'll smell like a brand new car.
Yeah, but how does it really work?
Is anyone familiar with the movie Holes, starring Shia LaBeouf, and his dad is just like trying to get this shoe spray that smells like nothing? It made me immediately think of that.
New car.
Yeah, but how does it really work?
Can't make it.
No, 9 o'clock! Focus all power on the vents. I love the smell of a new car in the morning.
Just hang on. The mission's almost over.
I did good, didn't I?
You deodorized the hell out of him, soldier.
How did you do this? Did you just get an all-around green screen on the floors, too? And then just he wore a green screen pant with all red clothing? I guess that would work.
You know, I have no idea. It just does. In the fight against car stink, Mother's Odor Eliminator and Refresher stands victorious. Click the link below to get your car back to fresh.
Okay, looking good, boys. All right, now let's pick
If anyone why are you always doing this with your neck? It feels good. My neck hurts.
a little bit.
Back to fresh.
Okay, looking good, boys. All right, now let's pick up the pace a little bit. Holding the crankshaft is the crankshaft support bracket, which uses little pressed-in dowel pins to stay perfectly aligned. The rear main seal inside the rear main seal housing keeps oil from leaking out of the back of the engine. If you own a car from the 90s, this is leaking right now in your driveway. Go check it out. I'll wait.
Oh, this
See, I told you. Now the front main
2012.
seal is, I'll wait. See, I told you. Now the front main seal is actually situated in the oil pump, and the oil pump is directly powered by the crankshaft. As it spins, the oil is forced through the galleries, constantly lubricating all of the engine's components. It is also sent through the oil filter, which catches any contaminants in the oil before getting to those important components. Now feeding the oil pump is the contaminants in the oil before getting to those important components.
How often should you change that?
Now feeding the oil pump is the oil pickup tube, which draws oil from the oil pan, which is kept sealed with the oil pan gasket. Now the oil pan is oftentimes called the oil sump, and it's where you'll find the oil drain plug, which lets you drain oil before you do a change. This thing right here, drive-through oil shops hate these things.
So this is upside down, and this would be the facing the ground under your car.
Okay, let's flip the engine over to get ourselves the proper perspective, because the engine is translating the up and down motion of the pistons into a rotational motion. That rotational motion of the engine, it can get a little jerky. So a flywheel is
okay, so it's the movement of the pistons themselves in this process of compression and depression explode that moves through the transmission, the tires.
attached to the motion of the engine, it can get a little jerky. So a flywheel is attached to the back of the crankshaft to help smooth out some of the engine's rotational motion. The flywheel is cast with teeth along the outside of it, and those hook up with the starter motor. That's just a small electric motor that gets the engine spinning before combustion can take over. All right, so that covers most of the rotating assembly, but a lot of the action in the engine occurs at the top of the combustion chamber in the engine's head. Now this mounts on top of the engine block with the head gasket ensuring you got a tight seal. Not only does the head seal off the top of the combustion chamber, it also houses all of the intricate pieces that control airflow. Yeah, a lot of pieces. That includes things like the intake and exhaust valves, which let fresh air into the combustion chamber and lets waste gases out. The valves are held closed by valve springs, which are held in place with valve spring retainers. The valves are pushed open using the camshaft. In our engine, we just have a single camshaft controlling both intake and exhaust, but other engines could have up to 4 camshafts. And the camshaft is made up of offset lobes. So
yeah, because I wondered how you'd make sure that the exhaust smoke would go out the exhaust way and not where the air is intaking. But obviously, they have these timed right so that it's sucked in when these are up and it's blown out when these are up. So
as the camshaft spins, which is inside the camshaft bearings, those lobes push on rocker arms, which pivot on a rocker arm shaft and push on the valve. The valve runs through a valve stem seal to keep that oil lubricating this whole assembly and keep it inside the combustion chamber. So as we spin the camshaft, you can see how the lobes push against the valve assembly and the valves open and they close. Now, when assembled, the entire valve assembly looks like this. Okay, cool. Now let's put the head on the engine.
So guys, essentially, so far, so
and the valves open.
This thing right here, the work that the piston is doing is where the work is transferred to your the spinning of your wheels. What's it called? The axle. What? It turns into the power of your car moving, right? So that makes sense. And so you have a fuel injector that's sprayed in with a spark plug. So it just sucked in air by going down. But it was also pushed down by the explosion, meaning, you know, it can still provide force when it's going down. And then it's pushed back up, which compresses that air it took in. A spark and fuel is injected into that compressed air. A spark plug ignites it. The explosion happens while this thing is closed and this is open. So the explosion, but you would have to time it perfectly. Wait a second. But you want all of the explosive force to go into pushing the piston downward, which would mean that you would want to keep the exhaust exit closed for as long as possible so that some of the force provided by that explosion doesn't just escape through the exhaust instead of pushing the piston down, right?
Now, when it's
So that's the basics. Fuel inject, spark plug, air intake, suck it in like a bike pump, compress it, spark, ignite, out the exhaust way, repeat, out the exhaust pipe, the explosion pushes it down, rotates the thing, rinse and repeat.
assembled,
Right.
the entire valve assembly looks like this. Okay, cool. Now let's put the head on the engine. But where did the engine go? Oh, good job. Good thinking. Now let's get that head on. Okay, so we want to make sure that air is going into the engine at the right time and exhaust is leaving the engine at the right time. You wouldn't want a valve opening in the middle of a combustion stroke. So in order to synchronize the timing of the valves to match the timing
Do you have a second valve?
of the pistons, we can just synchronize the rotation of the camshaft with the rotation of the crankshaft. So to do that, we need a few gears and a timing belt. A cam gear is mounted to the end of the camshaft to time the cams, and a crankshaft gear is mounted to the end of the crankshaft to drive the camshaft. But the timing belt doesn't just turn the cam gear. It also powers the water pump, which is responsible for sending coolant throughout the engine block to prevent it from overheating. And we're going to come back to cooling in just a minute. But first, we need to keep tension in the timing belt using a timing belt tensioner. And the way we to prevent it from overheating. And we're going to come back to cooling in just a minute. But first, we need to keep tension in the timing belt using a timing belt tensioner. And the way we link our cam gear, our crankshaft gear, and our water pump gear together
Tension in the timing belt.
so that everything is in time is by using a timing belt. Now, to prevent any dust or other things, debris getting into those planes, we need a timing belt cover. And then on top of our precious valve assembly is protected by a valve cover. Now that the valves controlling our air intake and exhaust are in time and the motion
Guys, so is that the same concept that they used to make it so that you could have machine guns and early propeller fighter planes that are timed with the rotation of their firing rate is timed perfectly with the rotation of the propeller so that it can shoot from behind the propeller but still never hit it? Is that the same concept?
belt cover. And then on top of our
Stay
precious
hydrated.
valve assembly is protected by a valve cover. Now that the valves controlling our air intake and exhaust are in time and the motion of the pistons is in time, we need to ensure that the combustions happen in time as well. So like we mentioned earlier, each combustion is set off by a spark plug. Now unfortunately, the 12 volts from a car battery isn't sufficient for a spark plug to create an arc. So an ignition coil uses induction to increase happen in time as well. And the motion of the pistons is in time. We need to ensure that the combustions happen in time as well. So like we mentioned earlier, each combustion is set off by a spark plug. Now unfortunately, the 12 volts from a car battery isn't sufficient for a spark plug to create an arc. So an ignition coil uses induction to increase the voltage from 12 volts to something like 40,000 volts. In our case, the ignition coil is found inside a distributor, which makes sure each spark plug fires at the correct time via the rotor. The end of the rotor receiver 1,000 volts. In our case, the ignition coil is found inside a distributor.
The ignition coil, so the coil that sends the spark is
Like 40,000 volts. In our case, the ignition coil is found inside a distributor, which makes sure each spark plug fires at the correct time via the rotor.
Okay, so even this thing is attached in a way to the other way those things were attached. That's awesome.
The end of the rotor receives electrical current from the ignition coil. So as the camshaft spins, the rotor spins, and it comes in and out of contact with 4 terminals in the distributor cap. The end of the rotor receives electrical current from the ignition coil. So as the camshaft spins, the rotor spins, and it comes in and out of contact with 4 terminals in the distributor cap. As it touches those terminals, an electric current is sent to a corresponding spark plug via a spark plug
So
wire.
that's a 4-cylinder engine.
And that is what sparks and ignites our air fuel mixture to create combustion. Now with all those those sparks going off thousands of times a minute,
I want to know, how do you time the opening of the exhaust exit of the combustion chamber enough so that you harness the greatest amount of combustion to the push down force of the piston and therefore more power, but without it like exploding, harming the vehicle, or without enough time where the air intake valve opens and exhaust fumes exit there. I would love to know just how do they find that perfect medium.
create combustion. Now, with all those sparks going off thousands of times a minute, we need to keep the battery charged with an alternator. Now, the alternator is held in place by an alternator bracket.
Guys, just fast forward if you want, or just original link to the video, top of the description. I know I pause a lot, but I'm not going forward not knowing what he just said. I'm not doing it.
And that is what sparks and ignites our air-fuel mixture to create combustion. Now, with all those sparks going off thousands of times a minute, we need to keep the battery charged with an alternator. Now, the alternator is held in place by an alternator bracket and an alternator tensioner. Inside the alternator, that is where all the magic is happening. An electric current is induced by spinning an electromagnet. That electromagnet is spun by the alternator pulley. Now, driving that pulley is a harmonic balancer. Sometimes this would just be a crankshaft pulley, but our pulley is integrated into the balancer, which helps dampen vibrations in that rotating assembly. And the way we get the alternator pulley spinning is by means of an alternator belt. Now, with all those little explosions going off every second, engines, they can get hot, like really hot. And since the crankshaft is always spinning, the water pump will always be spinning as well. But sometimes, like in cold weather, going off every second, engines, they can get hot, like really hot. And since the crankshaft is always spinning, the water pump will always be spinning as well. But sometimes, like in cold weather, you actually want the engine to warm up a bit. So this coolant pipe exiting the pump leads to a thermostat housing, which houses the thermostat. So the thermostat is technically a valve that slowly opens and closes depending on the coolant's temperature.
To allow antifreeze?
The thermostat closes and the coolant is redirected back to the engine to keep warming up. As the coolant heats up, the thermostat opens, directing the coolant out of coolant hoses, making its way to the front of the car where it enters.
Humans are so freaking smart. Humans,
the radiator.
Far and away my favorite animal. It's not even close. I'm sorry. I love you, dolphins. I love you, chimpanzees. I love you, dogs. Humans are the best. They're my favorite.
Out of coolant hoses, making its way to the front of the car where it enters the radiator.
And if I could just shut up.
Temperature. When the coolant's cold, the thermostat closes and the coolant is redirected back to the engine to keep warming up. As the coolant heats up, the thermostat opens, directing the coolant out of coolant hoses, making its way to the front of the car where it enters the radiator.
That's so amazing.
And attached to the radiator is a cooling fan which helps dissipate the heat into the air before the coolant returns back to the engine. Now, throughout this process, as coolant heats up, it expands. So the radiator cap allows that expansion to happen at a set pressure.
So this is at like right behind the grill of a car?
At the top, it expands. So the radiator cap allows that expansion to happen at a set pressure. If the pressure gets too much, a spring in the cap compresses where coolant will flow over into the coolant reservoir. Now, for an engine to run properly, the ratio of air to fuel and combustion.
Sorry, I don't want to just simplify it to like humans are so freaking genius, which they are, but it really should, like, no, I'm not talking about any one human or even one generation or two generations. I'm just saying, like, learning about stuff like this, of course, makes me incredibly humble, taken aback by like the people who made the big contributions to be able to think this stuff out and create an engine. But all of the things that you know must have happened through trial and error, like, oh, wait, but how do we make sure when it gets too hot, we can have something that changes the airflow? When it gets too cold, we can help change the airflow to help it. And just having all of these different things just makes me just all of the for engines are amazing.
Reservoir. Now, for an engine to run properly, the ratio of air to fuel and combustion chamber is absolutely critical. So we need to control the airflow going into the engine's intake ports right here. Now, starting from outside the car, air goes through the air filter, which is in the air filter housing. Now, this gets rid of any major contaminants before going through the air intake pipe and past the throttle body. Now, the throttle body houses a butterfly valve that is controlled by the gas pedal, and it determines how much air gets into the engine. The more air, the more fuel, the faster you can go. The throttle body connects to the intake manifold, which splits apart into 4 runners, one for each cylinder in the engine. Next to the throttle body is the idle air control valve.
Does that mean that the first cylinder closest to the opening of that valve that opens with your gas pedal will get the most power, and the least power will be the furthest one down on this, connector, just because the air.
Next to the throttle body is the idle air control valve. It's a little bypass valve that can allow more or less air to flow into the intake manifold to compensate for different air temperatures and densities, and that helps maintain a smooth idle speed. Now, after combustion, the exhaust gases from each cylinder converge into an exhaust manifold, and then they go through a front pipe into a catalytic converter, a freaking thief's favorite part of a car, where a chemical reaction converts really bad emissions into only kind of bad emissions. That exhaust gas flows through your
What if you make 2 chemical converters?
exhaust pipe, reaching the muffler, which quiets everything down, and then finally out the tailpipe. Now, some of the combustion might actually get past the piston rings and into the crankcase below. And in that case, the gases will be routed through the PCV system, which stands for positive crankcase ventilation. This includes an oil separator, which is just a box with baffles to ensure only the blow-by gases escape, a PCV valve, which is just a one-way valve, and a hose that leads back to the intake manifold. That way, any potential harmful fumes will have a chance to get burned up during combustion. Okay, so where are we at? We covered rotating assembly, timing, cooling, airflow. There are just 2 main pieces left in this puzzle. Next up, we need to talk about the brains of the car, the electrical control unit, or ECU. So the ECU manages nearly all of the electrical functions in your car. It also processes signals from various sensors to optimize engine performance. Some sensors are just position sensors that tell the ECU the timing of everything, like the crankshaft position sensor, the cylinder position sensor, and the throttle position sensor. Other sensors let the ECU know information about the elements moving through the engine, like the coolant temperature.
Sorry if in case I missed it. Did I hear right that the putting your foot on the gas pedal doesn't even just does it release both more air and fuel injection, or just increase the air? Did I miss that?
Cylinder position sensor and the throttle position sensor. Other sensors let the ECU know information about the elements moving through the engine, like the coolant temperature sensor, the intake air temperature sensor, and the O2 sensor. That lets the ECU know how much unburned oxygen is in the exhaust. The manifold absolute pressure sensor, or MAP, lets the ECU know how much air is getting to the cylinders. And all of those sensors are linked together by the wiring harness. Okay, we're almost there. We covered the rotating assembly, the timing system, the intake and exhaust, the electrical, the cooling, and the lubrication systems. The only thing missing from our engine is the fueling. As you can guess, the fuel starts in the fuel tank, gets sucked up by the fuel pump, which includes a fuel filter to keep out some of the larger contaminants. And that pump sends it down fuel lines until it hits the fuel rail. At the end of the fuel rail is a fuel pressure regulator to maintain the correct fuel pressure, with any excess being sent back to the tank via the fuel return line. The fuel you want, it goes through the injector, spraying fuel into the combustion chamber so that your engine can run. And that is
we're missing an injector.
Oh. Here you go. And that is every single part of an engine explained in 14 minutes and 37 seconds. Thank you guys so much for watching this and everything else at Donut. We'll see you next time.
Fantastic video. I love all of the I love everything about it. It's phenomenal. Would appreciate any answers to any questions I had, guys. You guys are awesome with that in the comments. As you can probably tell, I'm not great with car knowledge. I love machines. I think they're so cool. I love thinking about the processes and generations and shoulders that were stood on to create such machines. And yeah, I love learning about how this worked. And this definitely helped me learn more about how an engine works than any other video I've watched. So appreciate any comments. Love y'all. Hope you're all doing well. If you're not doing well, emotions are fickle, my friend. Chin up. You'll be good soon. Don't worry. See you guys next time. Bye. Keep learning.